Okay. Well, I'm here with Peter H. I've talked with him before. He's been talking to me for years, trying to convince me that creation teaching is not the reality, and I believe that the reality is the biblical teaching, and it's about reality. But anyways, we're going to be addressing the quote unquote time light problem a little bit, see if we can figure something out. So, do you have anything you want to start out with, Peter?
Well, let's start out with what is light. Okay, light is basically a photon, so it's just a little particle of energy. It's not even a particle. Well, is it a particle or not? I don't know. It's a photon is what a photon is.
Energy packet.
Yeah, sure, whatever you want to call it, or a little string, or whatever it is. Yeah, we can look at it as energy too. It occurs when an electron goes from one valence, like, you understand how an atom works? You got like different valence levels.
Little bit, slightly.
Okay, so if you have an atom, you have the center which has protons and neutrons, or possibly no neutrons, because hydrogen is just one proton with one electron spinning around the outside. Now, just like in if you could picture a solar system, like our solar system, you got the sun in the middle. You could think of that as the center of the atom, and then you got planets orbiting around. So you got Mercury, you've got Venus, you got Earth. In an atom, your orbits of electrons are at different levels. So if you think of the sun as the center of the atom, the first valence, where the first place where the electrons can spin around, that's valence level 1. You could have up to 2 electrons in that valence level. Okay.
Yep.
An atom is kind of balanced. So if you got 2 protons in the middle, you can have 2 electrons around the outside. And I am oversimplifying it to try to make my point. If you have more than 2 protons in the middle, let's say you have 3 protons in the middle, then you're going to have 2 electrons going around the first valence level, and then the next orbit would be the second valence level. You could have, I believe, 8 electrons in that level. So let's say carbon, for example. Carbon, I think, has 6 protons in the middle, some neutrons. It has 2 electrons orbiting in the first valence level, and then it's got 4 in the second valence level, right? Uranium, which is, 250 or 200 something, 254. Anyways, it's something like that. It has multiple valence levels. So it's 2, 8, 8, 16, and then 32. Anyways, so the way a photon gets created is you have an electron. When you heat up, let's say if you heat up hydrogen, if you heat it up enough, get enough energy in it, the electron will jump from one valence level to the next. So it'll jump from orbiting closer to orbiting further away. When it falls back down, it creates a photon. So it absorbs energy, and then if that electron jumps back down, it creates this burst of energy, which is a photon. Now,
okay, that's from hydrogen.
Well, that's from hydrogen, from any atom, right?
Okay.
You can give it energy, and it could cause the electrons to move into a different valence level, and when it drops back down, it shoots out a photon.
Okay, that sounds good.
Yeah, so that's basically how it works. So it's just energy, and then it's releasing the energy. When it jumps back down, it has to do something with that energy it releases as a photon.
And it's
that's
from
basically
heat.
that's basically what a photon is. Now, I might be getting a few little things wrong here, but because This is like
But
from 40
it's
years ago that I've learned all this stuff.
it's from heating it up. It's so like if you put an electrical current on it, it might vibrate more, and then it'll heat it up. And that's what.
It's by applying energy to the atom that will cause these to jump from one level to another. When they drop back down, they release a photon. So let's say you have an antenna, right, like a radio antenna. You can have electricity going up and down, creating energy, inserting energy, and then it releases that energy and it releases a photon.
Yeah.
Because radio waves is a photon. It's a type of light. Just that it's not visible light,
It's
but
not
it's the same
visible.
thing.
Yeah. Okay,
Yeah.
but it is a photon, though, right?
It is a photon, yeah. So X-rays are photons, radio waves are photons, gamma rays are photons, cosmic rays, I think, are photons.
We just can't see the entire spectrum.
Yeah, we can only see a very small spectrum. Now, that's also the spectrum that our sun produces the most is visible light. So that's why we're able to see it, because evolutionarily we evolved to take the most, density.
According to your belief.
Well, sure. So it makes sense that the amount of electromagnetic radiation, photons, that's released from the sun, a big chunk of this is in the visible light spectrum, which we've evolved to see. Okay. Or we're designed to see. That makes you feel better. Okay. So, but there's all kinds of other ones. There's infrared, right? Like heat. Infrared heat. That's also electromagnetic radiation. So it's the infrared. That's below visible light. Now, some animals can see the infrared. We can't, right?
Right.
Owls, for example, I think can see in the infrared, or yeah. So the way we know that the speed of light, you watch the video, other ways that we know that the speed of light or the speed of electromagnetic waves or photons is pretty consistent in space is because we have satellites. We have the Voyager satellites. We have the one that just went to go see Pluto.
It's our observation from where we are as to the speed of the photon.
So let's talk about that. Okay, so if we're moving away from somebody, or if somebody's moving at a faster speed, the general relativity kicks in, and
that would be special. Speed has to do with special relativity, right?
Speed has to do with general relativity. I believe deals with
gravity,
with time dilation, space-time, and how space-time is. Or is that special relativity?
But they both have to do with special. They both have to do with time dilation and distance dilation. But one is caused by gravity. The other one's caused by speed. So the speed is the one that causes the special relativity, and the gravity is general relativity.
Yeah. Again, I studied this stuff in one chapter 35 years ago.
Yeah, because I've been thinking about it a while, because I'm not too mathematically inclined yet, but I do think of what they're saying as to what's happening and stuff. So,
well, the answers are in the math, right? Like that's where you can see. Well, if they quantify it,
which has been verified, pretty much been verified with the collision of the neutron stars.
Well, it's been verified like a million different ways.
The gravitational waves, but I think the gravitational waves have been detected, or distance dilation has been detected for the first time with the interferometers, with the two neutron stars colliding, where they could see the light and they could detect the gravitational waves.
Yes, but that's fairly recent.
Right, exactly. It's the first time, but it has been detected, distance dilation.
Yeah, Yeah, and that's some other type of wave that we really don't know too much about. Um, but
Yeah, it's another kind of wave, and it's not very much like you said just before. It doesn't vary that much.
yeah, well, gravity is kind of like a magnet. Um, Not the same ratio of a magnet, but it's kind of the same as a magnet. Where if the magnets are far apart, they don't really the, the amount of force that they're applying to each other is so little, you might as well not even count it. But
But
if
I
your magnets are really close, the effect of
yeah,
the magnet is going to be very, very strong, and you won't even be able to keep them apart.
but they have a
Um,
thing in gravity where they say the reach of gravity is infinite.
yeah,
So
that's true. But
what I seem to think is that the combined gravity of all the black holes in the universe is what's dilating time and distance.
okay, so let's
Mostly.
let's take a
And
look at a
and
let's
it's
take
and it's affected a little bit by the gravity of the earth and the gravity of the sun and stuff.
okay,
But
yeah.
it's
So, but let's look at the math.
because
Okay,
you can leave the earth and you're still in dilated time and distance.
okay, yeah, that's all true. That's all right. But the to understand it, you have to look at the math. Okay, and what the math tells us um, is that if you increase the distance by 2, the effect is reduced by a quarter. So just like if you have a ball, right? If I double the size of my ball, I need 4 times as much fabric to cover that ball. If I
Yeah.
double it again, then I need 16 times what I originally of my original size of my ball. I need 16 times the amount of fabric to cover that ball. The same thing with gravity. So um,
Well,
if I'm
we still have a
100,
certain measure of time though, and a measure of
yeah,
distance, and the
okay,
measure of distance and time doesn't alter that much if you go out into outer space.
um, okay. So let me explain the. I think it's called the inverse square law. Anyways, I could be wrong about that. I may be thinking about something else. So if you double the distance that you are from the Earth,
But I know what you're talking about. I have heard
yeah,
that. Yeah,
The Earth's gravity is going to affect you a quarter as much.
yeah,
If you are 4 times the distance away from where you originally were, the gravity effects of gravity is be 1/16th of what it was. So you can see once you start going away from your source of gravity, the
yeah.
effect of that gravity on your photons is going to get less and less and less
Well,
exponentially.
gravity. That's the thing that I want to point out is that gravity is not. I mean, it doesn't affect photons because the photon is massless.
But it does affect space time.
Right,
And space
right,
time, it gets warped. And the
right,
light, even though to the light, it's traveling in a straight line and there's no forces acting on it,
right,
and it's
right.
always acting in a straight line. But if it gets close to a gravity source, that gravity source will bend space time.
It's
So
gravity that I mean, it's space time that's affected, not the photon.
that's right. The photon always thinks it's going in a straight line and it never ever moves from a straight line. So space itself it gets distorted,
Right.
which is really weird.
Well,
Um,
not
it's
really. If you
well,
understand, it's not so bad.
okay, exactly, but it's not intuitive. It's not that something that you can understand without trying
Well,
to
it's
understand. You know what I'm saying?
so so with the gravitational lensing, we do agree that light is traveling at different speeds.
Um, it's not traveling at a different speed. It's going through a time-space distortion. So just like
Right.
a lens,
It's all traveling at 186,000 miles a second or 300,000
yeah,
kilometers, right?
yeah.
But it's the space time that is allowing it to go faster or slower.
It no, it still is going the same
Yeah,
speed.
it's going the same speed in the space time, but depending on how much time is slowed down and
how
how
much
much.
space, is being distorted
No, no,
would
no, no, not.
depend on
It's
how much.
space. It's space time. It's both space and time. It depends on
Yeah,
how much time is slowed down and space is contracted. That will affect the the speed of light. That's what my point was.
yeah, but it's relative to the distance of the source of the gravity.
Because if there was no effect, there wouldn't be any gravitational lensing.
So, for example, if we look at a moon that goes and travels behind Jupiter, right? We don't see this distortion until it's right as it's right next to Jupiter.
Right,
Then we can see the distortion. When it's just a couple degrees off, we see zero distortion because the effect of gravity is more of a local thing, like a magnet, as opposed to so if we looked, for example, at Pluto, there's nothing between us and Pluto. There's nothing distorting that light
right.
that gets reflected off of Pluto that we
But
see.
you understand that I'm comparing one frame of reference with another frame of reference, right?
I think so. But if you want to make your point,
Yeah,
go ahead.
because the speed of light is constant within a frame of reference. If you jump to another frame of reference and compare it to the previous one, not going to be the same.
Yes.
Not going to be the same frame of reference. It's in other words, there's one square that's traveling at 186,000 miles per second. The other one's traveling at 186,000 miles a second. Only in one of the squares, the second is going to be slower and the distance is going to be contracted a little bit. That's what
Yeah.
gravitational lensing is.
Yeah, I understand what it is. Like it's bending space time. Um, as the photon goes straight through, space itself is
So
bent.
when you compare one frame of reference to another one, you're getting you're getting two different speeds of light in reality. In other,
No, the speed of light is still the same.
because that's what's causing the lens effect is that the speed of light is being slowed down more in one place than it is in another place.
No, it's not being slowed down. It's being bent because space
Well,
itself is being bent.
but it has to be slowed down though, because it's just like a lens. When you have a lens, a glass lens, it's traveling slower through the thicker part of the lens than it is in the thinner part of the lens, and depending on the curvature of that lens will determine how much is bent. And so between the one frame of reference and the other one, depending on how much is bent, depends how much the light is bent.
But it doesn't slow down.
Yeah, it does slow. It has to slow down. Just like
No, because
in
it's not
with a
traveling through anything. If you have gravitational lensing from
yes,
say a
because
galaxy,
but you're not. I don't think you're listening. You have two different frames of reference. In one frame of reference is like we'll just say it's like our frame of reference. We got 1 second and 186,000 miles. The other one, you have another frame of reference where the second lasts longer. In other words, instead of saying 1,001, it'll be 1,001. So it takes longer for light to travel less distance because the distance is contracted. So my question is, which is the reality? Is the one speed the reality, or is the other speed the reality? Then, if you go out away from any black holes, any gravity, or as far as away you can get from gravity, then you'll have a faster second. So it'll be 1,001. And then not only is the second faster, the distance is greater. So not only you're going to have a faster second, you're going to have a greater distance for the photon to travel. Then in special relativity, where the photon is not affected by gravity, it's going to be arriving instantly because it's not affected by time and space, by the dilation of time and space. But when we look at it, we're looking through the lens of time and space, and we have all these different lenses. And which one is the correct one? I would say the correct one is the time it takes for the photon to arrive, not being affected by gravity. That would be the correct one, which is instantaneously.
Okay, well, let's dissect that. First of all, light doesn't move instantaneously. It moves at the speed of light.
No, we are affected by gravity. We don't move instantaneously.
Yeah,
That's
but the amount
that's
of gravity that
that's what
we
I'm
are
saying.
the amount of gravity that we're experiencing is so small
No, it doesn't
compared
matter.
to the
It doesn't
gravity.
matter.
It
It
is.
doesn't
It
matter.
does
There's
matter.
still there. We still have dilation of time and distance where we are. The question
Yes,
is how much dilation of time and distance, and which
you're right.
dilation of time and distance is the correct dilation or
You're,
correct
you're
speed.
right. You're right. It's the math that gives us the answer.
No,
Um,
because you have different speeds of light. You have the speed of light near a black hole, you have the speed of light where we are, and you got the speed of light away from everything. Those are three different speeds of light with three different frames of reference, but the speed of light is actually traveling at different speeds. When you compare each of the three photons, the one near a black hole is going slower to the one where we are compared to the one far away from us, which is going a lot faster. And the real fast one is the photon itself that's not affected by gravity. It's just traveling through space, like you said.
um,
So that's my
okay, but
question. That's
there's
my question I'm putting to the scientist is which one is the correct speed of light? That's why Einstein was so emphatic about
okay, okay,
saying
okay, okay.
there's only one speed of light. Yes, there's only one speed of light, but there's different parameters of the speed of light, different rates of time, and different measures of distance, because there is no absolute measure of time or distance in the universe. There is no single
Okay, I understand.
measure of time or distance in the universe. So you see what I'm saying?
I see what you're saying. Um, but there's a couple of things that I'm trying to dissect what you're saying. First of all,
I just
light.
want to know which is the correct speed of light, because
So I'm gonna
three
we'll break it down and we'll figure it out.
we have three speeds of light, and we have four speeds of light if you count the photon itself.
Well, let's break it down now. Um, First thing I have to ask you: do you understand what red shifting is?
It has nothing to do with anything that I'm talking about right now.
Okay, so but do you know what that is? I just want to make sure you're not confusing that with speed.
No, no, it has nothing to do with what I'm talking about.
Okay.
That's just the extreme distances is what you're talking about.
No, what I'm talking about is the frequency. Okay, like for example, if you have a wave,
No, I'm
right?
not talking about the frequency. I'm talking about one frequency.
Okay,
Okay.
because the difference in between infrared, radio waves, visible light, gamma rays, all that is the
Is the
frequency.
frequency right? Right.
Yeah.
No, I'm not talking
So if
about. I'm talking
something,
about the light
okay,
coming from a galaxy far away. It's all the same frequency coming toward us.
okay. So what we know is if light is traveling
because
through a vacuum.
it's not a different distance. The
Okay, I
photons
know, but
aren't traveling
just
different distances.
yeah, but
Okay, go ahead.
if you let me explain something, then we can proceed. Um, Light traveling through a particular medium will have different speeds.
No, but
So if light's
I'm not talking about traveling through a medium, just space and time.
well, you're talking about it lensing and then light slowing down
Well,
because of the
but it's
lensing. It
all
doesn't do
no,
that.
but it's only through space and time with no slowing down of the photon.
Okay, so let me get to my point though. Um, if light's traveling through a medium, we know it travels at different speeds. It travels different speed through water than it does through air, than it does through a vacuum.
Right,
In space, it's basically a vacuum. Like
right.
the density of space is about 6 protons per square meter.
So the only thing that's changing it is the dilation of time and distance,
Okay, so but just let me get to my point, and then we can.
whichever measure that is.
I know, but let me get to my point, and then we can discuss it when I finish making my point. So see, now you're distracting me. So light in a vacuum travels at a certain speed. Okay, because there's nothing in empty space, it travels in the same speed no matter what the distortion due to gravity is.
It's all 186,000 miles a second, no
Yeah,
matter where
it's
you are
it's
in space.
traveling that fast, and it travels that fast consistently, and it travels in a straight line according to the light.
Exactly.
Now, what gravity can do, it bends space-time. So it doesn't slow the light down. It's not going through
No,
a
but and
medium.
you're not listening. You're not hearing what the
Well,
problem is.
I'm trying to explain the
No,
way
no,
I
because
understand it. So
you just said it's not slowing it down. So you
okay,
didn't hear what the
I
problem
did
is.
hear what you said. What I'm trying to do is I'm trying to explain the way I understand it, and then we can compare what you're thinking and what I'm thinking
Right.
to see where the
Because
mistake.
there it's not going through a medium. It's the only medium is going through is time and space, no matter where it is, and it's still causing gravitational lensing, which means it's space is being bent, and it also means that it's it's slowing down the light more in one place than it is somewhere else.
See, but it's not slowing down the light at all.
It it,
That's where
it
that's the problem. That's where
because
we have a problem.
no the problem is that we're talking about three different frames of reference and four if you count the photon. We're not talking about the same frame of reference. It's constant in the frame of reference. Now, if the parameters of that frame of reference change, it's going to change the speed because it's changing the time and it's changing the distance. So if you change the time and the distance, it's going to change the speed. That's my point I'm presenting to the scientists. Because speed is determined by what? It's determined by time and distance.
Okay,
That's
so
how you get the speed. And if you have a different rate of time and a different measure of distance, you're going to have a different speed.
so what you're saying is that it's going to travel through a larger or lesser distance because of the gravitational lensing.
No, because of the gravity dilating time and distance at different rates or different amounts.
Okay, but gravity distorting space-time is a local phenomena. It's local to that source of gravity.
But it's still you're still seeing different speeds of light.
Um, from me as an observer watching light pass by
Yeah, as an
a
observer,
galaxy getting bent.
because we are in this dilated time and distance. We are inside of it. If we are close
Yes.
to a black hole, we would be in that dilation of time and distance, which would be longer seconds and shorter distances. Not much,
Okay.
but it would be a different
Yeah,
measure.
but let's let's skip black holes for right now because black holes is a very local thing. And
I mean, we're
if you're
talking
close
about
to a black hole,
dilation. We're talking about gravitational lensing, which is usually caused by black holes.
well, it could be caused by anything. Um,
But do you understand what the problem is? That you have a different measure of distance and different measure of time, or different rate of time and a different measure of distance.
okay, let's say everything that you say is 100% correct. We'll just start there. Um,
But you
what?
understand
Okay,
what the
I understand
problem is.
exactly. I think I understand what you're saying, but I'm trying to find where you're going wrong. And I think
Well, you're
one of the
assuming that I'm
areas
going wrong. You gotta point out
I'm
what's
not
wrong with what
assuming
I'm
it.
saying.
That's what I'm trying to explain it to you, but you have to let me talk in order to do
You
that.
gotta point out where I'm wrong.
I'm trying to, but you keep interrupting me, so let me make my point. Um, because
It's harder than what you thought, isn't it?
talking to you, yes.
Go ahead. Go ahead. Go ahead.
Okay. But let me talk uninterrupted for just a minute to make my point, and then we can discuss the point once I've made it. And I'll let you know when I've made my point. Um, So the problem with the way you're thinking is the math. Um, we're like I put in the post there. We're
No, no, no.
traveling at 500 and some meters
There's
per
no
second.
problem. There's no problem.
Okay, so we're traveling at 500 and some meters per second, where light is 300,000 meters per second. Or is it kilometers? No, it's kilometers a second. So we're traveling at
Yeah. Well,
500 and
let's.
some kilometers a second, and light travels at 300,000.
But we're basically
Because,
standing still, though. For all intents
yeah,
and
so
purposes, we're standing still.
if you look at that formula that I posted, okay, in order to determine the difference between, uh, to quantify what the difference is between
Com-
if we were
but
moving away from,
compared to the speed of light, we're standing still almost.
pretty much, and the amount of distortion of space-time due to the speed that we're traveling
Is
is
minimal.
nearly zero.
Yeah, I agree with that.
So when we look at a galaxy and there's nothing between us and that galaxy that's
But it
4
has
billion.
nothing. I'm not talking about speed. We're talking about general relativity. We're not talking about special relativity, unless you're talking
I
about the
understand that.
photon. Unless you're
I
talking about
understand
the
that.
photon
Yeah, I
and
understand that. I understand that.
not experiencing time or distance.
Well, if we look at something like Andromeda Galaxy that's 4 million light years away, okay, if we see the light that's coming to us, and if there's nothing in between us and the Andromeda Galaxy, there's nothing to distort the space time and stuff.
Right.
Oh, I have to take this call.
Right. I agree.
Okay.
Don't leave your mic open. Yeah. Well, I wonder if anybody in the chat can see what I'm saying. I'm not. Haven't been reading. Jim Barack, are you a fellow student of JJ? That's Illuminati. I use.
Hi.
I used to host.
I'm on
I
this
used,
call and I'll be on this call for a little bit. So I'll
okay.
get back to you.
All right. That's okay.
All right.
I'll talk to the people in chat.
Yep.
Okay, Jim Brock. You you post content, a fellow educator on YouTube, or types contact. Jim Brack goes way back. Ronan, I see you are interrupting. Who's interrupting you? Are you interrupting me, Ronan? No, I'm just kidding. Pete must not believe in electric universe. Red Fang, LOL. He's not right, but he won't budge. Well, what's not right? You have three different frames of reference. They're different frames of reference because the measure of distance and the rate of time are different in each of the three frames of reference that we're talking about. And this is what causes gravitational lensing. So it's not in dispute. Gravitational lensing is not in dispute. What we're trying to understand is what is causing the gravitational lensing. And if you understand general relativity, you'll understand what the cause is, and it's the dilation of time and distance, or they say the bending of space that's causing the gravitational lensing, which is true. It is the bending of space, but it's also the slowing down of time. Because if you have a lens, you'll have light being slowed down more in one place than it's being slowed down in another place, and that's where you get the focal point. That's where you get the lensing effect, is from the slowing down of the speed of light. And when you try to spear a fish, that when you're looking at an angle in the water, you're not seeing the fish where it actually is because of the bending of light. Because light travels at a different speed through water than it does through air. Oh, I see. Happy, happy, happy. Good call. Okay. Can't stand me online. Yeah. Yeah. Okay. Yeah. Yeah. It's hard to please everybody. That's one thing I found out. And if you can't please everybody, then you got issues. So that's why Paul says it's better if you're single. That way, the only person you have to please is God, which is true. But if you're found, he also said that if you're married, stay married. If you're not, if you find yourself not married, stay not married. You know. So that's the advice of Paul. And he says it's not. He says it's just an opinion. It's not the word of God, but it's just an opinion that you can do more if you remain single. That's his opinion. He said. Yeah, Paul said if you're willing to accept it, to remain single, but not everybody is going to be willing to accept it because some people believe they have to have you know a relationship with the opposite sex. But he says if you're willing to accept it, to remain single, then you're better off. Opinions made it into the inspired word of God. Yep.
And back.
Yeah, but he let people know. He let us know that it was just an opinion. It wasn't what God was saying. Okay, go ahead, Peter. Sorry.
Yep, I am back. Um,
So you had a chance
okay,
to
so
think about it a little bit.
no, I had to take that call. I've been playing telephone tag with my cell phone company and for like 4 or 5 months, trying to
Yeah,
sort out a problem where they overbilled me.
yeah, that's rough.
Such a waste of time. Okay,
You know what they did to me today? I mean, yesterday.
but
We have street parking. You got to park on the wrong right side of the street. I made sure I parked on the right side of the street, and they billed me for being parked on the wrong side of the street. So now what am I supposed to do? They gave me a ticket because I was in the right place on the right side of the street, and they thought I was on the wrong side, and they gave me a ticket for it because we're on the street, it's not marked. It's marked on the next street. It's not marked on the street, and the guy whoever gave me the ticket just assumed I was on the wrong side for whatever reason. But
well,
it
you
was
pointing the wrong direction.
no, no. I was in the right. I was because there's Wednesday side and Thursday side, and it was Wednesday, and I was on the Thursday side. So then when I go to move it, I go to move it in the middle of the night, and there's a parking ticket on it. I said, "You dumb people." And I looked at it. Sure enough, he billed me for being on the wrong side of the street when I was on the right side. So now, so then I moved it. I put it on the other side, and I didn't get a ticket this time. And it was on a busy street, which otherwise would have been towed. Anyways, so much for that rabbit hole. But it's annoying. It is annoying. I'm telling you that much. I sent an email complaining about it, but I don't know. I'll just pay the fine. I'm not even going to go dispute it.
Well, you should dispute it.
If I have to. No, it's not worth my time. And they got this virus SARS thing running around. I'm not going to waste my time with it.
No. Okay, good. So you're being safe.
Yeah, because
That's good to hear.
I could dispute it, but I'm not going to because I don't even have time. To me, it's just wrong. I'll just send another email if they don't respond, whatever. Leave it at that. And if they
Usually,
don't,
there's a phone number on the ticket as well. You could just
oh
phone
yeah,
it.
yeah, I have to call. Yeah, I have to call. You're right. Got to call.
Yeah, but yeah, for me, a lot of times it's not about the money; it's about the principle of the thing. Because if they're going to screw me over, they're going to screw 10 more people over, and
Right. I said,
Eight of
I
them might
said,
just pay it and say the hell with it, I don't care. And
I said I try to do right to the city, and it's the city has to do right to me too.
yeah, and somebody who's making this mistake is going to make it again, and then you're going to get another ticket.
Yeah, so
So
I'll call him up. I'll call him up.
yeah. Okay, so when we're looking at a like the Andromeda Galaxy, we can see it clearly. There's nothing really too much obstructing our
Right.
view of
There's
it.
no there's no different frame of
Yeah,
reference that we're
yeah.
looking through.
So you agree that now that is actually so many millions of light years away, correct?
Well, through the lens that we're looking through, that's according to the calculation that would be that's why I'm asking, that's why I'm questioning which is the reality. Which one is the reality?
Yeah, and like I said, it's all in the math. Like how much
Because
effect
because
is our
we are
yeah, okay,
affected
I understand. I understand. I
by
understand.
gravity. We are
I
affected
understand.
by gravity, but the
I
photon is not
understand.
affected by gravity.
I understand all that because
So I want to know which is
and that's what I'm trying to answer. If you let me
real
say,
speed of light. The real
okay,
so when the photon leaves the star, how long does it take to hit your eye? That's what I want to know.
well, from the Andromeda Galaxy, it's 2.5
Or
million
anywhere,
years.
anywhere. No, no,
Well, it takes
that's through the lens that we're looking through it,
go okay. So this lens,
through the
you're
lens of
saying,
dilated time and distance. Yeah,
yeah, but
that we are
we have to
affected by.
quantify. Okay, okay, but we have to
We are
quantify.
affected by
I
gravity.
understand that. I understand that. You keep saying it over and over again, and it's not like I don't understand. It's the matter of how much. Okay, I could have some water in my.
But we're affected a lot by gravity because we have a second that lasts a second and distance that is 186,000 miles.
Okay,
Instead of as opposed to a distance being infinite and time being instantaneous.
okay. If I go to the ocean and I fill up my bucket with water, and I take that bucket out of the ocean and I put it on the shore, I just reduced the amount of water that's in the ocean by a bucket. Does it make any difference
Except for
to
where it's raining and where
okay,
it's evaporating.
whatever, whatever. Okay, I make it a lake. Okay, I take a glass of water out of a lake. I just reduce the amount of water that's in that lake.
A pond, yeah.
No, well, a lake.
A pond.
Has it made any difference to the size or shape or the appearance of that lake by being removing the water out of a glass of water out of the lake?
Well, it's just a little bit less.
But can you tell the difference? If I do it on one side of the shore and you're on the other side of the lake, and I take a cup of water out, can you tell when that cup of water has been taken out?
It's a small fraction. It's a small
Exactly.
fraction. So you're not
Exactly.
going to
And your time space dilation from looking at the Andromeda galaxy to us
is
is like a
immense.
glass of water
Where we
out of
are, it's immense.
it's an immense amount of
The
distance.
dilation of time and distance. Where that's why I said that's why I was explaining to you. Even if you leave the gravity of the Earth and you go into outer space, you're still in time and space of a measure of distance that's not too far away from our measure of distance here on Earth, and the rate of time is not that much difference either.
But see, there's a formula
But
to
it
figure out
is
the
but it
difference.
so it's almost but it's almost the same. So something is dilating time and distance, even if you get away from the Earth and Jupiter and the Sun. It's you're still in dilated time and distance.
Yes. And it's just like my glass of water out of the lake. You're not gonna there's so little of this
No, but what are
happening.
you comparing it to? Are you comparing it to the photon that's not being affected by gravity?
Okay.
When you are being severely affected by gravity. Otherwise you wouldn't even exist. I mean, that's what makes our existence possible. It's a fabrication of time and distance that makes our existence possible as physical things that take time to occur.
Okay. So let's do an experiment then. I'm on the Earth and I'm looking at Jupiter. Okay. Um, As the Earth orbits, at some point in time, we're moving away from Jupiter. At other points of time, we're moving towards Jupiter.
And
So,
you
and the
probably don't
speed,
feel
I
the
can't remember,
difference.
what are we traveling at? Like 50 kilometers a second or something, 60 kilometers a second. So we can see the difference between the, we can see the time dilation between when we're moving away from Jupiter to when we're moving towards Jupiter.
That makes sense. Yeah.
It does. So we'd have to say, well, what is the difference between when we're moving away from when we're moving towards? Can
Yeah.
we calculate that? And the answer is yes. We
Yeah.
could tell the difference, but
Yeah.
the difference is so small that it
That's
really
what I'm
is.
saying. That's what I'm saying. But
Yeah,
compared to the photon, it's great. It's
no,
a huge difference compared to the photon. With the
no.
photon experience, it experiences no time and infinite distance.
Okay, so we travel at 30 kilometers a second, right?
No,
So
but
I gave you that.
remember the speed is minuscule compared to we're talking about general relativity that doesn't have to do with speed. The speed is not going to change anything very much. The speed we're traveling is not going to affect anything one way or another very much.
Okay, but then why is it that Jupiter looks exactly the same whether we're
But
moving
it
towards it or
but
we're moving away from it?
it does take where we are, even if we went into outer space away from everything, it would we could still count 1,001 and would be 1 second. So time and distance are still being dilated even if we go away from everything because of all the other black holes around the universe which have an infinite reach.
Again, the universe is basically empty. It basically has
No,
nothing in it.
it's full of black holes. There's black holes
But
everywhere.
no, it's full of emptiness.
Black holes which are huge amounts of mass, matter and mass.
But they're very concentrated and very local.
It's what it's what dilates time and distance. Remember, the Bible says that the Earth is stretched out like a tent. Those are the tent poles, are the black holes around the universe that are dilating time and distance and stretching space and pulling it into the black hole, causing the vacuum.
Okay, but that effect is like a magnet. Where you're really close, you're going to really feel that effect. If you're further away, you're not going to feel it at all.
Yes, you are, because you're still in
It's
dilated
much
time and
less.
distance. You go away, you can go away from all the black holes, all the everything as far as you can. You're still going to have a second that's almost 1,001 and a distance that's still 108, almost 186,000 miles. So what
Okay,
I want to know is which is the correct speed of light in order to measure age and distance correctly.
yeah. And
Because
what I'm trying
if
to
you get
explain.
multiple measurements of the passing of time, you're not going to get the correct age of the universe.
Okay, and what I'm trying to impress upon you, okay, is it's relative to the speed and it's relative to the amount of gravity.
Especially if you extrapolate
Gravity,
light years.
gravity distorts space and time, right? That's what gravity does. But
It
as you move away
dilates.
from the
It doesn't
source,
distort. It
as
dilates. Gravity
right,
dilates time and distance. It
as
dilates.
as you move away, the effect gets reduced. If you double your distance away from the gravity source,
No,
you have 1/4 the effect.
you're just talking about extreme time and distance dilation compared to.
No, extreme time and distance dilation is a local phenomena where you're
But
close to the
I'm
gravity
not
source.
talking about extreme distance dilation. I'm just talking about gravitational lensing. That's not extreme distance or time or distance dilation. That's not extreme. Extreme is when you get near a black hole where it's dragging space into the black hole. That's
That's right.
extreme.
But what you're talking about is what how that affects what we see when we look up into space,
No,
correct?
I just want to know what the real speed of light is.
It's 399 or 299 something something something. Um, it's like 300,000 kilometers a second
In the
approximately.
frame of reference. That's what I'm keep trying to tell you. That's in the frame of reference. And if you go to another frame of reference, you'll have a different measure of time and a different measure of distance, and it's going to affect the speed. That is
Okay.
what gravitational lensing is,
So if
plus
we're
the
on
bending,
Earth,
plus the fact that it bends the light.
okay. So if we're on Earth, we're standing on Earth, and we're going. We look at it right now, and then we look at it 6 months from now. Okay. So 6 months from now, we're on the opposite side of our orbit,
Right,
right? What's the
right.
difference between today and 6 months from now?
You're just at a different angle,
Okay, but we're going in a different, instead of going this way, we're going that way, and
different direction.
maybe
Yeah,
some way we're going with the
yeah.
direction of the galaxy. Other times we're
But
going.
it's not going to affect it that much.
That's my point. It's not going to affect it. It's going to affect it so little.
Yeah,
You need a super sensitive instrument to be able to detect it, because it's so little. And
and
that's what I'm
yet
trying to
we
tell you.
and yet we
That
have multiple speeds of light because we have multiple measures of distance and multiple rates of time. Do you understand when you have different measures of distance and different rates of time that it's going to affect the speed?
Well, just like the cup of water out of the lake, the devil is in the details. You have to quantify it. If there's no difference for us standing on one part of our orbit and standing in the same place and on the other part of our orbit where we're going different directions,
Well,
right?
let me give an
We're traveling in
illustration
different
because
directions.
I don't think you're really understanding the effect here. So let me give you an illustration. You have put your hands far apart and count 1,001. Okay, that's let's say your hands represent far apart. They represent 186,000 miles. And from the time it takes you to say 1,001, the photon travels from one hand to the other. Now put your hands real close together and say 1,001, but instead of saying 1,001, say 1,001. Now, which rate of the photon traveling from one hand to the other is faster and which one is slower? You
The
get what I'm
speed.
saying? You can't have two speeds of light.
That's
I
right.
mean, if you do have two speeds of light, then it cancels out the validity of the speed of light.
Yeah. And the speed of
Yeah,
light in
yeah.
a vacuum
So
is well known.
which is the real speed of light? No, that's it's all in a vacuum. Nothing
Yes.
changed. The only thing changed was the frame of reference and the amount of distance and time dilation.
Well, you being an observer, maybe traveling at a certain velocity, and me being a
No, it
stationary
has nothing to
observer,
do with speed.
we would
Nothing to
we would
do with speed.
we would both see the light traveling at the same speed in a vacuum.
Nothing to do with speed. The only speed that we're talking about is the speed of light and which one is the correct speed of light. So which one is the correct speed of light when you say 1,001 with your hands far apart or 1,001 with your hands close together? Which is the correct speed of light?
Yeah, I really don't understand your.
No, no, no. See, that's the whole problem is
No,
that
I don't understand your
you don't
dichotomy because it makes no
understand
sense.
there's no because there's
How do you get a
different
slower?
frames
How do
of
you get a
ret.
slower?
See,
How do you,
see the speed of light didn't change. It's still 186,000 miles a second no matter where
we
you
agree with
are.
that
No matter where you are, it's 186,000 miles a second. The only thing that
in a vacuum?
changed, the only thing that changed was the rate of time and the measure of distance, which changes the speed of light.
Okay, and you have to
So you
quantify that.
have you have two you have three speeds of light. Which one is the correct speed of light? You got four speeds of light if you're counting the speed of the photon
There's only one speed of light.
in the frame of reference. But when you change the parameters of the frame of reference, you're going to change the speed of light.
Again, if you
That's
change
what
the
that's what I'm saying, and you're I don't even think you even understand yet. Okay, when you have dilation of distance and time, you're changing the rate of time and you're changing the rate measure of distance. So even though it's still 186,000 miles a second, you're changing the speed of light because you change the rate of time and the measure of distance.
Okay, by how much?
It doesn't matter.
It's the only thing that matters. How
It
much does it
doesn't matter,
change?
but listen to me. It doesn't matter because the difference between the speed of light in our frame of reference and the speed of light in the reference of the photon. The speed of light in the reference of the photon is instantaneous. And
No,
the photon is not affected by gravity the way we are affected by gravity, which slows down time to a quantifiable measure of time and to a quantifiable measure of distance where physical things can take place. It's a fabrication of time and distance, and we are not seeing the correct speed of light because we got three different speeds of light. Which one is the correct speed of light?
what are your values for the speed of light? You're saying you have three
186
different values.
186,000 miles a second, no matter where you are.
All right. So what differs is your frame
What
of reference.
what changes is the dilation, the amount of the dilation of time and distance. That's
And how
what
much is that
differs.
dilation?
It's quite a bit. It's
No,
extreme
it's
because
not.
it slows down. Yes, it is. It's very much different from the photon because the photon arrives instantly because it's not affected by gravity. But
No, the photon
we but
arrives at,
we are affected by gravity. And time and distance slows down for us, not for the photon.
yeah, but by how much?
It's considerably different because it's
It's
causing
not
gravitational.
considerably different. That's my
If
point.
it wasn't
It's
different, you
almost
wouldn't.
exactly the same,
It
and it's
wouldn't
so
cause
small.
gravitational lensing. Now,
Gravitational lensing
if
is the
you
bending of
admit to
space-time.
gravitational lensing, you are admitting to different speeds of light, different rates of time and distance. See, they tell you this stuff with tricky words. They talk about the bending of space and it's traveling through space in a space line, and just the only thing happens, it just bends. But it also slows down the photon from reaching you as fast. See, so that's the whole point for that. So there's really nothing you can say.
Yeah, because you're not making any sense. That's why there's
No,
nothing
you
you can
didn't
say.
tell me anything. You didn't tell me anything. You have three different. I just gave you examples of three different measures of time and distance. Which one is the correct one? And four if you're counting a photon.
Okay,
Which speed of
so
light? Tell me which speed of light is the correct speed of light.
the speed of light is always the same in a vacuum,
We
and
know
we can
that.
assume that we're always talking about it in a
We
vacuum.
know that it's the measure of time and distance that change.
Okay, and you're saying that
It's the rate of
gravity,
time. It's the rate of yes, gravity that changes the rate of time.
by how much?
So we are looking by a lot because we
No,
are
that's
looking
just that's where your problem.
we are looking through dilated time and distance, and we're seeing the photon take time to arrive when in fact it arrives instantly.
No, it doesn't arrive instantly.
It does.
No, light doesn't
As
travel
soon as it
instantly.
leaves the star, it hits your eye.
No,
Yes,
no,
because it's not affected by gravity.
it has nothing to do with gravity.
It has everything to do with the amount of gravity and whether or not you're affected by gravity.
Photons aren't affected by gravity.
So which is the correct speed of light then? I gave you examples of three different speeds of light. Which one is the correct one?
The correct speed of light is 300,000 kilometers a second, approximately,
Well, then why are you seeing gravitational lensing?
because it bends space time. It doesn't bend.
It,
It doesn't change the
it
light. It
bends space
changes the
and
space
time
time.
because it slows down the speed of light,
Okay, so
and it bends the direction. But it wouldn't have the same effect. It has the effect of bending light because the photons are slowed down.
no, the photons aren't slowed down. The photons are still going the same speed.
in that frame of reference, which has a different rate of time passing by and different measure of distance. Now, it's not that complicated to understand that you have three
Well,
different
okay,
three
but
different speeds of light because of three different measures of time and distance.
okay, I understand why you want to think
No,
that light
I don't want.
leaves a star.
I just want to know which is the correct speed of light
This correct speed of light is 300,000 kilometers a second.
through the lens that you're looking through.
The lens that you're talking
If you're
about,
looking through another lens, it's a different rate.
yeah, see,
If there's so let's say a black hole came around closer to us and changed the dilation time and distance so that time slowed down and distance decreased. That would change the that would change the time it takes for light to reach us. It wouldn't change the 186,000 miles a second would be the same, but it would have the effect of having the photons take longer to reach us, or according as if we measured it, it would still be 186,000 miles, but we have a slower second and shorter distances. See, but
okay,
you
but
do
no,
understand
no, no,
that you do
no.
understand that speed is determined by time and distance. You do understand that, right? So what would happen? What would happen if you increase the time and shorten the distance? What would that do
Well,
to the speed?
speed or velocity is distance over
what would
time.
that do to the speed? If you
If
increase the
you,
time, if you increase the time and shorten the distance, what would that do to the speed? It would go slower. And that's exactly what's happening in gravitational lensing. Because
but you haven't
I
caught the.
gave you the
Okay,
example
first of
of
all,
your hands far apart with 1,001 and your hands close together with 1,001. You just changed the speed.
okay,
Okay,
light.
you don't need to talk to me anymore. You need to go talk to your scientist and get an answer. That's what you need to do. Okay. I don't want to
No,
cut
because
you
what you're
off or
saying doesn't
anything
make any
unless
sense. You
because
just keep talking.
we really don't have anything more to talk about because you haven't given me any answers. You haven't given me any solutions and you hardly understand what I'm saying. So what you need to do now, you need to go to your scientist, whichever scientist you want to pick, and ask him the question and ask him which is the correct speed of light. You know, I
Well,
don't. If you had something to say, I wouldn't cut you off, but you're not saying anything.
I don't get a chance.
And
Okay, again, you're cutting me off.
I don't want to waste all my duck stream time, you know,
Oh,
or
you have to pay for this?
barnyard time. Well, no, it just if I take too much time, I'll use up all my time, and I'll have to wait till the next month.
Oh, really?
Yeah, I mean it's a lot of time, but if I stay on for hours, it ends up that it uses up all the time, and I have to wait a couple of days to to
Well,
replenish.
there's some things that doesn't make sense about what you're saying, and it's not because I don't understand it. It's because you just got things wrong.
No,
And I
don't say that I'm wrong. You got to point out something that's wrong
well, I'm
because
about
you're
to.
muddy. That's called muddy in the
You
water.
have to let
You
me talk in
no,
order
you
for me to.
have to stop muddying the water. You said, "Oh, there's things you're saying wrong." That's why you don't understand.
And I was
No,
trying to explain it.
first, all you have to do is just tell me what the problem is. Explain to me what I just explained to you, and then tell me what the problem is with it.
Well, I think what we need to do is we need to start what is a meaningful conversation. And that's when I'm allowed to make my point. Then we talk about it.
No, you
Then
have to
you
have a
can make
point.
your point.
You're not making a point. You have to have a
Well, I'm
point.
trying to, but you keep
No,
interrupting
you're
me.
talking about making a point. Just make the point.
Okay, but you have to be quiet
No,
for
you have to make the
30
point.
seconds so I can make my point.
You have to make the point. You're
Okay,
not making a point. I'm interrupting because you're not making a point.
because I'm not getting a chance to.
No,
Now,
you're not making a point. Make the point.
now Next time I'll host
Don't
this so I
don't
can mute
talk
you.
don't
So
talk
I can
about
mute you
talking
so I
that you're
can
going to
talk.
say something. Just say something.
The
It's
speed
not
of light
It's not
in a
hard.
vacuum, the speed of light in a vacuum is consistent.
In a given
That's
frame of reference.
yes, but the given frame of reference, you have to quantify it. If
Right.
you're saying that our gravity on the Earth it distorts things, I would say
No, it
yeah,
dilates time and distance. It's not
yeah.
distort. It's just
By
dilated
how, by how much?
because it can be a
Answer my question.
it
By
can
how
be a
much?
no. Listen to what I'm saying. It can be a big second or it can be a shorter second, a long second or a slow second. That's dilation of time.
How much does the Earth dilate space
It
time?
doesn't. It varies. It varies, and
But how much?
It's not very much. I mean, it's not very much, but it does. You do get different speeds of light
When you're saying not very much, are you
because
saying
if you didn't get different speeds of light, you wouldn't get gravitational lensing.
by again? It's a matter of how much this affects
Yeah,
what
it's
we
how
see. Correct?
much compared to the photon.
Okay, so quantify it.
So it's a lot. I just quantified it
No, just saying a lot
because
is not
with
quantifying anything.
a photon there is no distance. I mean there is no time passing of time and there is no distance
It takes time
because it's
for.
already there because it's not affected by gravity the way we are.
All right, let's take a step back for a
But
second, and
we
I'll.
are affected by
Can you
gravity.
please let me?
That's
I
why a
got.
second takes time. That's why there's a
The,
1,001 and
if you repeat the same thing over and over
to
again, it
travel
doesn't make it
distant
any more true
different
or
distance.
wrong than the first time you said it. Okay, so you just keep repeating
You're
yourself. I
not
don't know why.
saying anything. You're not saying
I
anything. Try to
can't
say
because you
something.
won't
No,
stop
you're
talking.
saying that I'm saying something. Go ahead and say something.
Okay, if you're on Mars and I'm on Earth, and I talk to you, I get on my radio and say, "Hey, jungle, how long does it take that signal to get to you?
In dilated time and distance, it'll take time. Yeah.
How much time?
A lot of time because we are affected by gravity.
Okay, how much time?
But I don't know. It takes a lot of time.
Well, it depends where
So
Mars is and where
which
the
is
Earth
the
is with
correct
respect.
time? Which is the correct time though?
That's just it. It's always the
If
correct
it varies
time
so
based
much,
on the distance.
if it varies so much, which is the correct time?
It depends on the distance between us and Mars. Correct?
Well, the distance varies.
Exactly.
The measure of distance itself is going to dilate. We just
Exactly.
detected the dilation of distance.
Okay. You don't have to use the word dilate. The
Yes,
amount
you
of
do,
distance,
because that's what we're talking about.
the amount of distance
It's not
between the Earth.
distortion. It's not traveling in a straight line. It's whatever.
Okay. Yeah, pointing out obvious things is not going to help us here. If you're on Mars and I'm on Earth and I send a radio signal, how long it takes depends on the speed of light, which is
It
300,000
depends
kilometers a
on
second.
the amount of the
It
dilation
just
of
let me
time and
talk. Let
distance.
me talk.
If you
So,
dilate time and
oh, for
distance, it's
fuck's
going to
sakes,
take time. It's
can you
going to take
please
time.
not keep repeating the same thing over and over again? I've heard you. Now let me say what I want to say.
Well, I would be fine with that if there wasn't multiple speeds of light or radio waves. But
Well, radio
you have all
waves.
different kinds of speeds of radio waves and light, and when there's supposed to be one speed of light.
Okay, that's wrong because it's just one
It's
speed
right
of
because otherwise
electromagnetic.
you wouldn't have gravitational lensing.
If you don't let me make any point, there's no point in
No, you have
talking.
to make a point. You have to have a
You
point to
have to
make.
shut up long enough for
No,
me to make.
you don't have a point to make. You're not making a point.
I am trying to make a point. Okay, we started at the beginning where I explained to you what light was, and that there's different kinds of light. There's radio
No.
waves.
We're talking
There's
about one kind of light, one visible
it's
kind of
yeah,
light.
they're photons, and the photons are at different frequencies, and the
And it
different
doesn't matter the
frequencies.
frequency. It's just one single
You're right. It
frequency,
doesn't matter the frequency. Okay, but
one single frequency.
so If my radio signal is sent from Earth to Mars, it takes a certain amount of time based on the distance.
Right, because we exist in time and space.
It
Fabrication of
based
time or dilation
on
of time and distance.
okay, you keep saying that. The
Yeah.
problem that you're having is you haven't quantified
No, the
how
problem
much
that
this
we're
distortion
having,
is.
the problem that we're having is that there's multiple variation, multiple amounts of the what you call the distortion of time that I call the dilation of time. There's multiple measures or rates of the dilation of time and distance.
Yes, which you have not quantified.
So which is the right one?
Like I'm trying to tell you,
Which is
it
the correct
really
speed of
doesn't
light?
make any difference. The correct
It
speed of
makes a
light,
lot
when
of
you keep,
difference.
what is the correct speed
It
of light?
makes a lot of difference
What is the speed of light?
because the photon arrives instantly.
It doesn't arrive instantly.
It
What is the
does
speed of light?
because it's not affected by gravity the way we are affected by gravity. We exist in a fabrication of time and distance. The
Okay.
photon is not affected by that fabrication. We are affected by a dilation of time and distance. The photon is not affected by the dilation of time and distance. And I don't need to talk to you anymore. I tried to be polite, and you're not telling me anything.
You don't
Go
give me a
go
chance to say
talk to
anything.
scientists. Go talk to scientists. Tell them what the problem. Explain the problem, and then come back to me. Because you have multiple speeds of light, and you're not telling me which is the right speed of light.
The right speed of light is the light that we agreed on, the speed in a vacuum, which is 300,000 kilometers per second. Okay, approximately.
Yeah,
So
I
we
got a phone call. Hold on.